Okay, so, second time around. We are now looking at the binomial distribution, and as we're looking at the binomial distribution, this is the other branch of the Bernoulli family, and this one is the bigger branch. This is the branch that, you know, if looking at the twins in the womb, this is the one that grew real big. This is the Arnold Schwarzenegger twin, and the other one was the Danny DeVito twin. The geometric distribution is Danny DeVito twin. If you don't know the movie Twins, don't worry about it. All right, so we are Bernoulli, which means that we have the three criteria of Bernoulli: success and failure, which is number one here. Observations are independent, meaning our sample size is less than 10%. The probability of success is the same for each observation. And then we have this statement right here, which is number two, nicely not in order, but there is a fixed number n of observations. So you know in advance how many times you're going to roll the die, or how many cards you're going to pick, or how many kids you're going to have. Okay? Now, if it is a binomial distribution, we can write it as a distribution. This is so popular that we're going to give it the name of binomial distribution with two parameters, which are n and p. Remember back before, we've seen this before when we talked about a normal distribution. We said a distribution was normal and we had two pieces of information. The most important pieces of information was the mean and the standard deviation. Now we have a binomial distribution, and the two big parameters that we need are n, which is the sample size, and p, which is the probability of success. Are you going to see this? Yes, you are. We've got two different huge functions that we're going to use. The probability distribution function, or PDF, assigns a probability to each value of x. And we use this when we want to find exactly how many there are. We're going to see why that is in a minute. Then we also have the cumulative distribution function, or CDF, calculates the sum of the probabilities up to x, meaning up to and including x. So what this is, this sums as it goes with a G, goes, it is cumulative. It is cumulative, it sums as it goes. Oh, we're almost running out of room here. Well, we don't need that thing over there. Okay. So suppose each child born to J and K has probability 0.25 of having blood type O. If J and K have 5 children, what is the probability that exactly 2 of them have type O blood? So here's what I'm doing. I've got 5 kids. I want to find the probability that 2 of them have type O blood. First of all, let's check and make sure that this is binomial. There are only 2 outcomes. Condition number 1, success and failure, type O or not type O. Condition number 3, blah, 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 blah. We are going to have less than, our sample is less than 10% of all children. Yes, okay. The probability of success, type O blood, is the same for each of the 5 observations. It's going to be the same for each of the 5 kids as long as J and K are still their parents. And then here's the thing that makes it binomial specifically. There is a fixed number of observations, 5. They're going to have 5 kids. Okay? So we've got a binomial random variable. So as we think about this, let's talk about what we're thinking is going to go on here. They're going to have 2 kids that are type O blood. That probability is 0.25. So I'm going to have a kid with type O blood. I'm going to have another kid, I'm going to write in front of this, with type O blood. What are the other 3 kids going to be? Well, they're going to be kids that are not type O. Not type O is 0.75. And I'm going to have 3 of those. So what I have here is 0.25 to the second power and 0.75 to the third power. Break out my calculator. 0.25 to the second times 0.75 to the third. And we get a value of 0.0264 to 4 decimal places, 0.0264. That's what our answer is. Okay, now, here's what's great. The calculator will do this for us, okay? If we think about what can happen here, you know what we're going to do? We're going to go back and we're going to insert a page here. If we think about what can happen here, what we can have is they can have one kid with type O blood, they could have 2 kids with type O blood, they could have 3 kids with type O blood, they could have 4 kids with type O blood, they could have 5 kids with type O blood. But the one value that we're missing is if they have all kids with type O blood, certainly they can have all kids with not type O blood. Every time that you do a probability distribution like this, or a model, we need to take into consideration saying, oh, they could have 0 kids. So there are 6 values here for 5 kids, because we always have that value of 0 successes here. So what we're going to do is we're going to find the probability of each one of these. Now our calculator is going to give us help with this, because what this probability here would be, it'd be the probability of having exactly 0 kids with type O blood. This would be the probability of having exactly 1 kid with type O blood, exactly 2. And what we just said is that that PDF function will do that for us. In the calculator, that is called binomial PDF. And the syntax in the calculator is N, P, R, and NPR stands for National Public Radio. So, N is the sample size. How many kids are they going to have? P is probability of success. And R is the number of successes we're going to have right now. Now, here's the problem that we have, is that the calculator says R, the rest of the world decides, no, 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 that's K. Fine, we can adapt. Okay? So, we'll go to our calculator, and we'll do this. Let's start off with filling out how many kids is the probability of 0. So, we're going to go to our second favorite button in the whole world, and our second favorite button is distribution. Second variable is distribution. And what we see here is, oh look, this is normal PDF and normal CDF, and this is the one that's replacing the Z table, and inverse norm. And we're going to scroll down until we find binomial PDF. Scrolling, 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 though the streams are swollen. Keep that calculator scrolling. Binomial PDF. There it is, binomial PDF. So I hit enter, and it comes up on the big screen. And it says binomial PDF. So I put in N and P and R, 5, comma. Probability of success was 0.25, because N, sample size, probability of success, 0.25, comma. Number of successes, we're going to start off with 0, and we get 0.2373. So as I make this model, and we'll come back because it's never going to work out right, and we'll come back here. Probability of having 0 kids, here's X, here's the probability of X, 0.2373. Okay, that's groovy. Now, let's go and do it again, and except for we're going to do it for 1 kid. And what I can do is I can go to second entry and call it back up and backspace that out, sit there and say, no, 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 I didn't mean 0, I meant 1. And we can do that, and we say, oh look, it's 0.3955. Lovely! 0.3955. Woohoo! That fits right in there so well. Okay, now, let's do it for 2. But here's what I'm going to do. I'm going to do these all at the same time. This is what's going to be super cool. So I'm going to go to Stat, I'm going to go to Edit, and I'm going to go over to L1. L1, L1, L1. And in L1, I'm going to put the values for R, the number of successes I can have. So I'm going to have 0, 1, 2, 3, 4, and 5. So I've got those in L1. Now I'm going to go to L2. And in L2, I need to make sure that I go up to the menu for L2. I'm going to do the binomial PDF all at one time for every single one of those. So I need to pull down my distribution menu again, and I'm going to choose binomial PDF, but I'm going to roll up from the bottom because it's actually closer. We're going to be here just a second. Wrong one. Go away. We'll come back in just a second. Second distribution. Binomial PDF, come on. Too far. Binomial PDF. And again, it's N and P and R, so it is 5, comma, 0.25, comma, but where's R? R is L1. There, you better go. And there's our list right there, and we're going to come back and see what it says in just a second.